good evening, all. We roll those opening sequences so I can get everything caught up, and we are running a few minutes behind, but we had a lot of wind where we are here in Texas. We've got the Gulf open wide, bringing that moisture up from the south. We had a wind gust here to probably about 30 knots, and you can see that on the surface chart here with the large area of warm air across the eastern U.S. So basically everywhere from New England out to the Great Plains and the southern Rockies. Temperatures much above normal. Looking at the scale here, we're seeing 10 Celsius degrees, so that's going to be about 15 to 20 degrees above normal. High temperatures across the country look like this, and it seems like in some parts of Texas they were even warmer than yesterday. We were seeing low 80s where we're at, lots of 70s up to Oklahoma and even Kansas, and we can see 81 there at Blytheville, Arkansas, and lots of 60s out here. And the general pattern that I can see on the surface chart is we've got the warm air right here. So that suggests probably a warm front going from about Alabama, Mississippi out towards Missouri. So in turn, that would kind of give us the idea that there's going to be some shear set up for the southeastern U.S. And that's kind of what we had today here. The 500 millibar chart showing a zonal flow across much of the country here. And if we put in the jet stream, we can see one very broad polar front jet coming into the west coast, covering much of this area, probably synced up to a certain extent with a 300 millibar chart, or 300 millibar jet, the subtropical jet. Got this trough coming through Texas and Missouri. And further out west, you can see this ridge along the east coast. So this area right here is where we're looking at some of the thunderstorm activity, and going underneath the jet like this. The patterns would support a warm front, something like that, with a cold front coming back southward like that. So we'll see if that's indeed the case. I pulled up the College of DuPage site. This is a pretty good way to view mesoanalysis data. So I figured I'd pull up a few images. I think we've got that squall line going into Florida, so let me bring that up here. And let's see, I don't think they... See, I'm trying to find if they give us radar. I think I may have to go into a separate chart for that, so let me go up to the products menu and I'll bring up radar. And there we go. We've got the squall line going through. Looks like the Tallahassee, maybe Gainesville area. I'm not too familiar with the cities there. But if we bring up the surface plot, you can see the very moist air ahead of that squall line. 65, 66 degrees out ahead of that. And behind that, you can see the outflow pool. Let's check out the capes. And I believe this was pointed out yesterday that this was surface-based cape. And we can see 2,500 joules per kilogram offshore. That's mostly modulated by the very high dew points off the coast. And then inland we can see more on the order of 1,500 to 1,000. Okay, let's check out the model pattern. Look at the thermal setup across the U.S. And it doesn't look like we quite have that front that we were suggesting on the 500 millibar chart. It looks a little bit different here. I could probably put out a little bit of a front right there. But the overall synoptic pattern is looking something like that. So pretty much a cold front from about the Memphis area, Little Rock area northward. And then getting out to the west coast gets a little bit more uncertain. The stronger thickness gradient appears to be in Washington and Oregon. And that probably, yeah, now it connects back up into this other system like that. So we'll just draw that very quickly. This is the new Pacific system coming inland. So we'll be looking for that to come in on the GFS. And here we can see that mesoscale convective system moving through Florida. Okay, for soundings, it would probably be a good idea to take a look ahead of this MCS. Tallahassee is probably going to be back behind the system, so we'll check out what that shows. Let's see, 68, there's a lot of humidity here, so maybe they are out ahead of the system. The best way to figure this out would be go to this next lab thing and drop the station plots and bring up the station identifiers. Because I'm not 100% sure where Tallahassee is. Okay, it's right, it's going to be right there. So about the time they did the sounding launch, we're going to be way back. See, this would be about 010. I would believe that they probably launched the sounding perhaps right before the squall line came through. So that does make that sounding a little bit interesting. And you can see how uncapped the air mass is. So lifted partial goes like that, only a very weak cap right there. So basically it looks like we have a proximity sounding right here. And this is the positive area ahead of this system. Looking at about 800 joules per kilogram in Cape here. And you can see that very strong shear out ahead of the system with a 50 knot jet up at about 800 to 750 millibars. This system, as we saw yesterday, is being focused mostly by the upper level energy coming through. We've been seeing this strong trough coming through the Mississippi River Valley this morning. And essentially the MCS is focusing ahead of this vorticity area right in that zone. And we can see that that's going to move quickly offshore. So by tomorrow the squall line should be out of the picture. We have another wave coming down from Missouri and Illinois. But by this time we would expect the moisture to be possibly no longer in place. We'll have to look for that on the GFS chart. But sometimes you can get another outbreak back behind the main system. And so we're just watching for the outside possibility of that. You can see the channeled flow here. Stronger jet core right there over the Atlanta area. This is going to be for tomorrow morning. And then a new jet coming on the shore like that. And let's see the large-scale picture. Looks like a lot of ridging into the central U.S. Trough coming on shore for Friday. Then we go into the weekend, trough moving on shore. We had this shear off into a cutoff low over the weekend. Looks like the model is still going for that scenario right there. And then I'll eject a few waves into the Texas area just a little bit after the weekend. Looks like the first main wave comes in on Tuesday. So we'll be looking at rain chances increasing about then. The main cold core low over North Texas on Wednesday. Ridging coming back in. And we've been mentioning the ChaserCon weekend. That still looks to be under the ridge on the 18th. And then after that, we're looking for the next system to come inland on the 20th. Okay, about that tornado in New Orleans, I pulled up some NextRad data. And here's a look at the storm that we had earlier today. This was about 11:30 in the morning. In fact, this frame was 11:23. And you can see not only a supercell and not only a hook, but you can see an actual debris cloud right there. So we'll zoom in on that. You can check that out. I'll set a dot here right on where that cloud is. And if I bring up the storm relative velocity, you can see what looks like a TVS signature. That contrasts very sharply with what we see with a meso. Let me see if I can bring this back further. Okay, so this is going to be more of a velocity signature in a meso. You can see it's a pretty wide couplet. So maximum outbound, the radar sight is up this way. Maximum outbound is right here. Maximum inbound here. So this is painting out a very wide rotation area, measuring about 2.5 miles in diameter. And then over the next few frames, you can see this condense into a TVS. So to a certain extent, we do have the couplet, the mesocyclone, but embedded in that is a smaller scale circulation right here. And position-wise, this is going to be, looks like, I don't know, it looks like that's going to be south of I-10. I'm not too familiar with the geography of New Orleans. I know that's on the east side, and that's the area that got pretty hard hit by Katrina. But right here, that's going to be the location of the tornado. We're seeing about 66 in. Yeah, about 65 in and 56 out. So that's about 100 to 110 knots of shear. And bringing up the spectrum width, this is suggestive of a debris cloud right there. Now, I haven't kept up with the news. I was up processing orders and email up until about noon or 1. Then I went to bed and got up actually about 45 minutes ago. So I'm just now getting caught up on all this, but definitely looks like the east side of New Orleans here. Classic supercell there. And if you were actually out chasing on this thing and were somewhere out in this area, you would have a pretty good view of whatever was on the ground at that point. And let's just run forward with the frames I have. The system mainly came together after passing the populated areas of New Orleans and really came together on the east side out here. And I believe a lot of this is just marshes and swamps. There's one railroad track that goes through this area, but you can see Interstate 10 well up to the north there. So that's a very classic signature right there. Very strong velocities. We're seeing 52, 64 in, 64 out. That's 128 knots of shear. That's a very good, very strong tornado right there. And let's see if I have any more frames here. This should have been prominently visible on the ground if there wasn't too much low cloud there. So that's going to be the last frame I have for that. So that is the New Orleans supercell this morning. Last frame there at 11:23. And the first frames I have on that going through the northern New Orleans area around 10:55 in the morning. So there you go. You can see that storm come together. And it would have been scary at that time to watch that come through. Looks like they had this other tornado warning for north of the lake up in the Slidell area. The Covington area, they had a warning on that. And doesn't look like anything that jumps out at me on the reflectivity. Same thing with the velocity. I'm not seeing anything on this particular storm. There was probably something out there earlier. So anyway, that was the tail end of that cluster that came through the southern Louisiana area. We had convection develop overnight in the Arkansas area, and then it spread through into the Mississippi River Valley area early this morning. Okay, I think we're about ready to head into the forecast and see what's coming up over the next few days. And let's see, we'll take a quick look at chat, see who we have in here. Looks like we got our usual crowd, Sue M there, and Andrew. Jeff is here, Michael Burrell, Sarah Wood, Alexi, Fun with Tech. Jeff says, let there be sound. Looks like we haven't had any problems just yet. Alexi, Ron, Jason, and Jeff here. Somebody said sound was off. Let me check. No, sound is good. Okay. Fun with Tech. Last night was interesting. 5 thunderstorm warnings, 1 tornado warning in Arkansas. Yeah, I took a quick look at that overnight. 2 tornadoes in the New Orleans area from Alexi there. New Orleans East tornado appears to be EF3, according to Jeff Lockwood there. Tree Nelson checking in. Fun with Tech saw 2 watches. Michael Burrell. Albany hit by another tornado today. Makes at least 3 or 4 for the same tornado these past 2 months. Andy White checking in from Northeast Connecticut. Ancient Astronaut checking in with a exact pressure reading. Andrew asks, why do I prefer spectrum width versus correlation coefficient with locating debris? To tell you the truth, I haven't looked at the correlation coefficient product very much. That might be worth doing, but I'll pull that up very quickly. So there's the correlation coefficient, and I haven't used this product very much, to tell you the truth. I never really thought about using that much for debris. I'm definitely pretty used to seeing that on spectrum width, and we can see it right there. Correlation coefficient. Let's see, what do we got here? Depressed values of about 70%. We're looking at the higher values of 95 to 100% for your traditional raindrops, which is all this. And so I think we would be looking at these values here. Yeah, that's interesting. I'm going to have to pay more attention to that for sure. All right, rain in Medford from the Escaney. Northern Covington tornado had a tornado emergency warning. Okay. All right, so let's go ahead and head into the forecast here. And this is a global model, so it's not going to pick out the details too well on this system to the south. And as we know, MCS is right down there in this area. So the GFS is not sampling that too well, but the larger scale synoptic patterns definitely picking it up very well, and we can see the front extending into Northern California right there. So heading into tomorrow's forecast, when we do the webcast on Wednesday, we should see this Great Lakes system push southward. A little bit of a cold intrusion into Texas here, bringing the cold air southward. But that's not going to make much progress south because we've already got the warm air advection setting up ahead of that ridge out to the west. So it looks like high pressure moving into Missouri. I guess we do pull in a little bit of cold air to the south, but it's probably going to be very shallow coming into Texas. I definitely see the ridging all the way down to the Rio Grande Valley, but I'm kind of skeptical we're going to get much cold air out of that. Lee side trough setting up in Colorado. There's the map for Thursday, and then going into Friday. There's what the system's going to look like. Just pretty much a cold lee side trough in Colorado. New Alberta Clipper coming south. I'm assuming that's moving towards the New York area. Front coming through California with a lot of rain, relieving the drought there. So I guess that's good to see. Saturday, system crossing the Rockies right there, and we can see the thickness band shifting into New Mexico and Arizona. So this is probably going to be a cold front working its way through the southern Rockies. Out in Texas looks dry, but this is a good setup here for downslope winds. We should see a pretty warm day here on Saturday, and possibly even the dry line getting established out in this area here. For Sunday, the cold air that's up to the north starts making its way south behind the system, which is now going through the Big Bend area, getting a bit of isotropic lift developing in this area. And by Monday, everything just continues sinking to the southeast right there. Lots of isotropic lift across Texas. Maybe a few emitted showers in that. And the system looks like it kind of stalls out along the Gulf Coast here. A little bit of an inverted trough up through East Texas right there. GFS going for enhanced rain chances right there. So at this point, it looks like by late next week, most of the cold air is focused on Ontario and Quebec, way up to the north here. And that's not in a good position to reach the Great Plains. You can see the Alberta Clippers are now becoming established over Minnesota and Wisconsin. And they just aren't making much progress southward. This one makes it to Arkansas, maybe to Oklahoma, kind of a backdoor front coming in here. But the focus on this is mostly into the eastern U.S., where temperatures will be below normal. And for California, it looks like more rain, more systems coming inland. And this next system will be crossing the Rockies on Monday around the time Chaser-Con lets up. It's going to be mostly elevated, I think, here. You can see it moves very rapidly eastward. That's another good sign that it's mostly elevated. And then that moves very quickly eastward around the 21st, brings in a shot of cold air southward into Texas. And this is 324 hours out, so we'll probably see the models flip-flop a bit on that over the next few days. Okay, I'll just take this one last question. Why was the big area of high spectrum width in the rain-free base? Okay, so we're going back to that radar image here. That's the correlation coefficient, spectrum width right there. Well, if we go back to the basics, we know that the gray here, this is going to be kind of a homogeneous distribution of particle sizes. So here we're talking about the rain out in this area right here. And then we have a higher diversity of particle sizes out in this area. Why that is, I don't know. That may be sensing non-meteorological scatterers. But the uniformity of this is kind of interesting, though. I'm not really sure what would be causing that exactly. Probably getting some, maybe a little bit of rain falling out of the anvil in that area mixed with smaller. That's a good question. I really don't have any theories about that. But normally what we see out ahead of those rain-free bases is mostly, I don't have any good examples, but we would see kind of a higher, kind of jumbled diversity, kind of like this. Maybe I'll bring up one image before I go just to let you see. Kind of fun to go through sometime. Let me bring up the spectrum width on this. There's the Rowlett storm. I think by that time it's probably heading out. Okay, not seeing a good example there either. We'll try the Conway storm here. But I guess what I'm showing you is usually when I see these areas out ahead of the supercells, they've got more this look right here. That's kind of what I'm going for right there. So just kind of a very noisy pattern. And part of that is because the signals are... That was weird. Okay. I guess the opening clip decided to run right there. All right. Sorry about that. That was weird. Okay. So let's try that again. I was just basically pulling up some imagery. This is the Conway storm here. That was a big F4. I think it was an F4 or F5 tornado. Affected the Mayflower area. And you see as you get out into the inflow air, this is the noisy pattern I was talking about right there. In this case, early on. Debris cloud is right there, not showing much of a, maybe a very small spectrum width signature right there. So, okay. That's about all I got. I've got dinner coming in here shortly, so I'll probably just wrap that up right there. And, yeah, that's pretty much it. Anyway, hopefully we'll see y'all tomorrow. I appreciate y'all watching, and take care. Thanks.